Okay, so we're going to talk about Visual Studio and traditional and all that kind of good stuff. So, throughout the conference this week, you've heard and you're going to hear an awful lot more about Visual Studio. It's a Microsoft development environment that we and many others believe is the best environment you have to develop software. Right, this is going to be a journey. It's a great developer experience, but only if your chosen language is fully supported. We already know that Synergy.net is fully supported inside Visual Studio. We've been showing you what we can do in Synergy.net for many years now. Last year we introduced you to the ability to develop traditional Synergy code inside Visual Studio, and this session will show you how to get to that editing utopia. I wonder today how many of you are living in editing utopia. But before we head gun-ho into Visual Studio, let's take a quick tour down memory lane. You all do it. Oh, I remember the Ristus days. In days gone by, we would use simple text editors to write the code. In early days, we had no other option. We typed whatever code we wanted and received no indication of correctness of that code. Any mistyped code was rarely spotted. There was no fancy color coding to show keywords or known language statements. There was no help when using external routines, no indication of arguments, requirements, and return values. And once you typed a bit of code, you would usually have to end up ending the editing session. After all, the editing was a simple text editor and knew nothing about how to build the code you'd just written. So you'd revert back to the command window, and perform the build. Often, this is where you would see your colleagues encountering build errors due to typing errors in their code or not calling external routines correctly. Of course, we didn't mock those who encountered such errors. We just advised them accordingly. So, several years ago, we integrated Synergy language into Slick Edit, and we introduced it as Professional Series Workbench. In a nutshell, it's a Windows-based development environment editor that knows a lot about our Synergy code. However, at its most powerful feature, the Workbench, it knows all about the Synergy language. Typing in known language structures like begin, using, etc., Workbench would complete the structure by adding the end or the end using. Less typing, less work, we all like that. Color coding highlighted badly spelled words or unknown syntax, so it was obvious that when you were typing something that may not be quite right, you got a visual indication. Using language routines displayed IntelliSense to help you write the correct code the first time. The IntelliSense would show the arguments, the details, whether they're required or not, and the structure of the whole call. You could even include your own IntelliSense for your own library routines. The end of the paper manual was nigh. A powerful build system was built into Workbench, and it provided the ability to prototype, build your libraries, your executables, and your mainline programs. Many people didn't adopt this build system and chose to continue with their individual build systems. Of course, we fully supported this. We allowed you to do this. However, as we'll see shortly, this may cause you some minor headaches when they move to the development environment to Visual Studio. The Workbench provides a number of basic project templates to help you define the right structure and build process for your chosen traditional Synergy target. Project templates were available for standard Synergy programs, object libraries, and executable libraries. Mainline programs were just that. Each source file added to the project is built into an individual mainline program, a mainline executable. You can define the object and executable libraries to link against and enable the creation of working DBR or traditional executable files. Object libraries were very useful for holding subroutines, functions, and even classes that rarely changed. So build them, put them in an object library. All source files were generally built together and placed into the resulting object library and forgotten about. References from this object library were made at link time, and the object code from the library was basically taken from that object library and added to the resultant executable. Similar to an object library in that all source files are built together, but this time the resulting library is an executable library. References from an executable library are made at runtime, and the executable library must be present on the deployment platform. No object code from the executable library is added to the resulting executable, or the DBR, and so the executable, the DBR, is much smaller, much leaner. These executable libraries are located both at link time and execution time using logicals and environment variables. The name of the logical when you link the mainline program is very, very important and must be declared and defined on your deployment machine. And we'll talk more about that in a little later. These project types at the bottom allow you to build the client requirements for XF Server Plus, which is still a valid solution today. Full support for the 3 clients, .NET, Java, and COM. Some of the tools available in Workbench include the Synergy Composer, which is important if you're developing UI toolkit scripts. The method definition utility is also available if you're developing XF Server Plus code. And there are several other utilities that you can find and run directly from the Workbench. Some of these tools are now available in Visual Studio, but the underlying project structure is not fully there to support them. So you can run Composer, but it doesn't know about your project. I always get this. One of the most powerful tools that you won't get with Visual Studio is Diffzilla. Diffzilla is the file comparison tool that's built into Workbench. It's cool and is always the first question I get. How do I compare 2 files? So, what's so great about Visual Studio then? Well, this session is not about showing you the cool features of Visual Studio. Marty, Jeff, and other people are doing that. This session is going to talk through how we take advantage of developing a traditional Synergy libraries and programs inside Visual Studio. Now, for many of you, this will completely replace your Workbench development environment. But, we'll be honest, maybe not for all. Not everything you can do in Workbench today is currently available in Visual Studio. And some things may never make it there. So, why do we need a great developer experience? It's just code after all. For a developer, the majority of your working day is spent at a keyboard writing code. The better the tooling, the better the productivity in my mind. Using tools that the cool guys use help us to retain staff and obviously find new staff. Showing a prospect around your company and seeing all developers using Notepad to write Synergy code gives the impression that Synergy is old. It's not old. It's valid today as it was 40 years ago. The tooling has a massive impression on how they conceive Synergy. So using the latest and greatest tooling is essential. And that's why we've been investing many man-hours into providing the ability to develop traditional Synergy code inside Visual Studio. We all have Windows machines today, so we already have the required platform. Our target may not be Windows, for example on Unix or OpenVMS. Currently, there's no tooling to provide the ability to really code within Visual Studio and build deploy on non-Windows platforms. If this is what you desire, and there's people in this room that do, then make sure you visit the Synergex website and vote to have these capabilities added to the wish list. The more votes an idea gets, the more higher up the wish list it goes, and the better Chris Vallendale will feel. You'll need to get Visual Studio to be able to do this, and there are a couple of options. You have the Visual Studio Community Edition, which is free, but there are strings attached. You have to be an individual developer, and you have to have a revenue cap. It's about $1 million, which probably runs most of you out. There is a professional version, which has everything you'll need to do everything in both Synergy.net and traditional Synergy. And then there's the enterprise version, top of the shop, with obviously a price tag to match. All versions are fully supported in traditional Synergy. You can easily theme Visual Studio to fit how you and your developers want to work. Of course, there's the standard blue appearance, as opposed to the dark one, and this is what you get out of the box. Most people change it these days. No matter how you make Visual Studio look, traditional Synergy development within it is cool. So let's take a look at some of the ways to start developing and move your development into Visual Studio. And remember, you've got to remember, we're still building traditional DBR, OLB, and ELB targets at this point. This is not developing or building Synergy.net. This is not a complete new development solution for you. It's just a different way of doing that development. This is the most basic of compilable projects, the mainline program. As the title indicates, it creates a single empty program within which you can write the code and build. Once the project template completes, you get the basic mainline program structure, and you can start writing code. Of course, editing in code, and we have the full power of Visual Studio. So we'll get language statements and routines, we'll have full IntelliSense, items in the editor will be correctly color-coded, based on what they are, as long as you have spelt them correctly. And obviously, it even knows about toolkit. We can add a few lines of code to make our program do something. And be honest, there's nothing better today than a Hello World using state-of-the-art UI toolkit as the rendering engine. Remember, this is traditional Synergy. We're cutting edge right now, completely cutting edge. Of course, we'll need to reference the UI toolkit library, and standard add reference options are now fully supported. Once the references have been made, you can reference your own object libraries and executable libraries as well. And you can build, run, and debug your programs. And remember, you'll be debugging your traditional code using the powerful Visual Studio debugger. And we'll probably look at that in a little bit, to be honest. Code modules that don't change very often, the logical library type is the object library. Define subroutine units in code. These can be new subroutines, or you can load and reference existing subroutines in your library projects. Of course, you can write and include functions into object libraries. And there's no exception to all classes. I'd like to think everybody in this room now is developing code using new sexy O syntax. I'll not ask for a show of hands, because you'll all tell fibs and not be honest, I'm sure. All of these compile units can be placed into an object library. Once you've built your library project, you can then link to it from your main line. Remember, when you link the mainline program, you're actually taking all the code from these functions and the object library and putting it into the resulting DBR. So it can get a bit bloated. Alternatively, you can create an executable library, or ELBs. ELBs can be created in just the same way with Visual Studio, and you add the same code, subroutines, functions, classes, etc. One of the things you'll find when you move from Workbench to Visual Studio is performance. It can slow things down. The MS Build subsystem will build everything it needs to, and this can cause builds to take longer. One trick, and thanks to Steve for referencing this, is to reference your OLB project in the ELB. This means that only the individual source files in the OLB project that have changed will be rebuilt and put into the object library. Then the executable library is built from the object library. So the whole process will be a lot quicker. For projects with large numbers of routines and files, this can make it significantly quicker. Other projects and mainline programs still continue to link against the executable library, not the object library, that sort of intermediate process. Like object libraries, when you link an executable library, the resulting mainline program contains only pointers or references to the executable library. This means that your executable program is much smaller, and it also means that your executable library needs to be deployed. It also means that if you change the executable library, you don't actually need to rebuild the mainline program. You just ship out the executable library, and as long as the signatures all stay the same, life is good. So we've quickly covered mainline project types for Synergy. We have mainline programs and library projects for our subroutines and functions and classes based on compile units. There are also multiple mainline projects, and as the name suggests, it allows you to include multiple mainlines and build each one individually. Any code that's changed in the mainline project will be built each time you perform a build. From the project window, you need to right-click the menu and select a particular program as your startup object, the program that runs when you hit the start in Visual Studio. Because we handle all that. Now, there's a new project type being developed, and I say being developed, that is not available in the Workbench, and that's the repository project. This project will allow you to build repository schema files into a repository and reference them in certain ways. Okay. The effort required is going to take to get to your development environment for wherever you are into Visual Studio will depend on many factors, many things. The scale of effort will be significantly decreased if the better the structure of your Workbench environment is. So let's talk about how to make things life easier and help you get the best possible experience from Visual Studio. There are a few key points that if you have set up in Workbench, then things become an awful lot easier. It may sound a little obvious, but if you make sure that everything builds in a folder or a project, and your include files are all there, and your repositories are up to date, things will be a lot easier. Sounds obvious, but you'll be surprised. The easiest way to get files into your Visual Studio project is to just reference them from a disk folder. So tidy things up before you get in there. Are you using the build or individual compile link options to update your executable libraries? If this is the latter, then you get problems. If your project builds under Workbench, the build system, then chances are things will build nicely inside Visual Studio. In Workbench, you can configure commands that can execute both before and after you build. Okay? So you might want to do additional processing. If you have these configured in Workbench currently, then currently we don't have the same capabilities in Visual Studio. I'm guessing it's going to be something we can look at. So you may need to make changes to the way you build things. But remember, Visual Studio and MS Build underneath it is going to take over the whole building of your code. So pre and post scripts may not be required. If you're using prototyping in 10.3.3b today, then you're more than halfway there. Well done. Just a side note, if you have prototyping pre-Synergy 10.3.3b, then you may still encounter build and prototype issues. Prototyping had a major overhaul for 10.3.3b, which we did talk about at last year's conference, and the changes may well break your builds. Honest, we're real sorry about that. If you think this may affect you, then come talk to us and let's see if we can help you sort of move forward. It's essential to understand here that Workbench uses source code to create tag files that allow your Synergy language to be aware. In Visual Studio, it has to be able to prototype and build before you get any IntelliSense. Check your Workbench projects, which compiler switches you are using, and make sure these are set in Visual Studio. Again, these are obvious ones, but you can miss them. This one sounds a little strange. In Workbench, you may have multiple projects in the same workspace, but reference libraries built by those projects using environment variables. In Visual Studio, include the projects in solutions and reference the solution, not an environment variable. This will ensure that you get full IntelliSense. When one routine in a library references another routine in a library, things are fine. But if that second routine references back, you get a circular reference. Circular references are not good and you need to be removed and resolved. We've got options to help you alleviate the problem and to try and identify the problem, and we'll come on to one of those a little bit later on. Let's take a quick look at some of the important project settings. This is an important change concept to understand, in my opinion. When we create an executable library, we default the output path to exedir. The exedir is the logical used to say not only where the library will be created, and this is the important bit, but how it will be referenced at runtime. In the common properties list, you'll define the environment variable, exedir. Now, the value of exedir is not a concern. I don't care where it points to, but it'll point to a folder on your disk somewhere. The important fact here is that when you reference this project, for example from a mainline project, it's the value exedir that will be used to locate the ELB. Okay? So it's when you reference the ELB that the mainline program gets a reference or a pointer to it. Make sure this environment variable is whatever your environment variable that you use today. And although this appears to be a slight difference, it could quite easily break your system when deployed. You'll not notice this when you build things. But if it's not the same as your myexedir, it will break your deployment. So be careful. You no longer specify the logical when you build the mainline program. You reference the project where that logical is defined. QRelax. For some of these settings may well be required if you've not gone through the entire code base and made all the required changes to enable full prototyping. Obviously, we'd recommend that you make the changes to improve resilience of the compiled unit. This reduces and eliminates the use of switches and only enhances the resilience of your executable code, which obviously can never be a bad thing. However, the switches are still there because we recognize it does take time to change it, test it, rebuild it, and do all that. So we put the switches there. To ensure that your builds are functioning correctly, you have a couple of options. If you use the -R switch on this will ensure that any routines in libraries can be found and resolved, which means you need to ensure that the correct libraries are referenced by the library being built. It's a sort of all-encompassing, make sure I can find anything at build time as opposed to run time. This has the advantages that it will highlight if you're trying to reference a library higher up the link chain, which of course will cause a circular reference, which is, as I've said, is not good. There's also a new option called R require proto, which does a similar job to the -R option, but notice, however, that the -X option is disabled. So if you set -R, it will disable the -X. So you may then get build errors because it can't find functions. Okay? This is what can get frustrating. You find something, you fix something, you change a setting, you build again and you get more errors than you did last time. Persevere. We have ways of helping you. Now, I've highlighted quite a few of the tricks to enable you to migrate your non-Workbench environments to Visual Studio and to develop traditional Synergy-based applications using the modern state-of-the-art tools. As always at SynergyX, we provide tools to help you along the way, and Syn2VS is a tool that may help you. Syn2VS is a tool that converts Workbench projects into Visual Studio projects. The actual Syn2VS tool is hidden away under a folder name within Visual Studio, and there's no pathological to it, so you'll have to go sort of searching for it to find it. If you have a super setup inside Workbench, which only uses the supported project types, and all code uses built-in subsystem and fully prototypes and all that kind of good stuff, then you may well be able to take advantage of Syn2VS. You can also use the optional command line switch that forces Syn2VS to check and resolve circular references, which, as we've said, the Visual Studio environment really just does not like or support. And the resulting output will be a Visual Studio solution and a collection of projects. So, you've gone from Workbench to Visual Studio with one tool. So why has this entire session not been about Syn2VS? Why leave it to the very end? Well, to be honest, my experiences of Syn2VS have not been great. Not because it's not a great tool, but every customer I've been to and used this, they all have such different Workbench environments and configurations. The tool handles simple generic configurations and often generates Visual Studio projects that actually need quite a bit of work. My experience thus far has been that it's often better to start from scratch and to get the Visual Studio environment you want, not what Syn2VS thinks you want. So, create projects, pull in and reference the right source files, make the source code build, and you'll soon have the very best traditional Visual Studio development environment, and it's all inside Visual Studio. Developing traditional Synergy code inside Visual Studio gives you and your development team the #1 development environment. Yes, there is a level of pain to get there, but the pain is most certainly worth it. I trust you've got all the information you need to take your traditional development into Visual Studio through this session and the other ones at this year's conference. We are here to help. Don't be afraid to ask questions or get advice on how to tackle the migration process. What I'm going to do is I'm going to bring up a virtual machine. I'm going to take you through a quick process of demoing taking a Workbench project through the process into Visual Studio. And unlike everything what I've just presented in that show, I'm going to use Syn2VS. So let's see what happens. I'm on an F drive, I've got a folder called NAHbase, and I've got a few things in here. Here are my Workbench projects. My VWP is my workspace, VTG is my project. And notice there's no solution files in here, so I'm not hiding a solution under the hood and I'm just going to open it up and you're all going to go, oh, that's amazing, it's all smoke and mirrors, it really didn't do that. I am really going to do this. I'm just being dead slow about it. So, what I will start off with is I will bring up Workbench. I'm going to open that said workspace that we just went to. I said it was on F, so I'll nip to F. I said it was in NHbase, and it is there, so I shall bring it in. This code is brand spanking new, okay? So, let's have a look at some source files. Let's have a look at TT, where's TT open? And if we have a quick look at that, this was written by a very famous gentleman by the name of Roger Andrews. This is not made up code. This is truly written in 1982 by Roger when we were back at CCAT. It was truly fixed, and these dates don't lie. You might not recognise them because they're UK based, but back 2012, 2013, this code is still in existence today. It still runs a business. Yeah, it's old cell-based Diebold code, but it's in Workbench. Okay, I'm going to build CCAT sub. So I'm going to use the whole build subsystem inside Workbench. And we'll very quickly see that it's prototyped. You saw the prototype, hopefully. It's building all the individual. There's lots of switches and things like that. It links it. It's created by OLB. Brilliant. The next one I'm going to look at very quickly, and this is a cut-down version. I'm not pretending that this is the full-blown system. Otherwise, I'd be here for 10 minutes instead of the 5 that I intend to be. But some utility routines that, again, if I use the build system within Workbench, it will prototype, it will build. Life is brilliant. And then the final one is my utilities, which again, written in 1984 by a Mr. Andrews. And I can build this, and again, it runs the build system. And I will actually then go and say, debug this. I've got AZ menu highlighted in my editor. I'll go into debug, and it will run. And it's a traditional Synergy program. I've got the traditional Synergy debugger. I can do step, and I can step into TT open, which was the routine that Roger wrote in 1982 that we've just seen the code for. And then I can do go, and I'll get a very simple cell-based menu up. Not going to go into the programs. This is not a demo about the programs. This is a demo about the environment. Okay, so we're going to use SynterVS. Now, obviously, I did talk throughout my presentation saying nothing about SynterVS until the end, so we're going to use it. So I'm going to open a command window, and as I said, the SynterVS tool is not very easily located, so we need to go to Program Files and Microsoft, and I'm not typing all that in because obviously I can't type very well. The Microsoft Visual Studio 14. And then I'm going to dir/s syn to vs.exe. Okay, I found it. And this is what I was saying. You've got to search for it a bit, but once you find it, life is good. Now, you could argue, well, why wouldn't you know that, Richard, seeing as it's in Visual Studio 14, Common 7 IDE extension, Synergex, Synergy DBL integration. You should know that. It just rolls off the tongue. Which in Visual Studio 14, yes it does. In Visual Studio 15, which is 2017, Visual Studio 2017, it's not in a Synergex folder, it's in an XYZ ABC123 folder, okay? So it gets a bit more complicated to find it. And every time you redo the SDI, I believe that folder changes. So that's one of the reasons I've highlighted the fact. So let's go to our F drive, and let's go to our NHBase, and I'm going to do that /syn to vs. So I'm just going to give it the workspace, and hopefully I won't get any errors and nothing happened. Well, SynterVS doesn't actually tell us whether anything happens or not. So let's see if we've got a Visual Studio solution. Yes, we do. So now we've got that, we can open Visual Studio. So I'm in Visual Studio. I'm going to open my newly created solution, which was on PC, F:/NHBase, National Hickman. It's got the same time. I'm not smoking and mirroring here. And that's going to bring in all the projects. So there's 3 projects, wasn't there? There was the CCAT sub, there was the utility, which was my mainline programs, and my utility subs. Fantastic. I can start editing, I can do everything. So, before we start editing, obviously we need a system that builds. So let's build the solution. Because obviously it's all built in Workbench, so it's all going to build out of the box. Oh, okay, maybe not. I'm not doing this to highlight that SynterVS has got issues or our environment has got issues. I'm only doing this to make sure that you understand if things are not right, the chances are you're 2 clicks away from getting it right. Okay? You will experience issues doing this, I'll guarantee it. But don't get frustrated, don't get downhearted. Just go, okay, deep breath, let me look at these. Some of them, you sort of think, well, I'm not really sure what's going on here. It says passkey not found. Okay? Well, it's there, but I don't know what passkey is. If I do a go to reference, it doesn't find it. I'm so frustrated now. I hate this product. I'm going to throw it away. I'm going to stay in Notepad. I never want to go near it. Deep breath. Calm down. Watch the video I've just done. One of the things that I said was make sure you're switched on. So if we, for example, look at the project properties for CCAT sub, let me just make it the active project, and go to the Synergy DE options, I said check your switches. This has a switch that says define variant equals 2. Okay, well, when I say check your switches, what I mean is go into Visual Studio, look at CCAT sub properties, go onto the compile tab, and notice, for whatever reason, rightly or wrongly, you've not set it. Whether SyntaVS didn't set it for you or not is irrespective. I've only used SyntaVS to get me here quicker, okay? The chances are you've forgot to set the switch. So set the switch, as they say. Now let's try and build. So everything should now build brilliantly. I'm now down to 12 errors instead of my 300 and 500, whatever it was. So I've still got errors, so things are not quite right. Now, for me, I'm not sure what's going on, but it looks like referencing. Oh no, look. One of the things is, these are all in my utility project, so these are mainline programs. Well, I've never prototyped mainline programs. Why would I ever prototype a mainline program? I only want to prototype routines that I call from my mainline programs. Okay, so what I can then do, I can look at in the utilities project, and go into properties, and I'm going to realize that I actually need to do a bit of relaxing. I should really maybe go and change code, but I won't. I'll do a bit of relaxing. That's why we left the switches there. Do things now build? Oh yes, okay. Oh, you didn't see it then, did you? It disappeared too quickly. Things now build. It looked terrible. I went from a working Workbench to a non-working Visual Studio, but 2 clicks later and I'm building. Take a deep breath, think what it's telling you, and you'll figure it out. If you can't figure it out, talk to us, we can help you figure it out. These are the sort of silly little things that you get frustrated about. So as I say, I'm not trying to pull holes in SyntaVS or this product or anything. I'm just highlighting that these sort of little things happen. So, if it builds, do we send it to the customer or should we run it first? Okay, let's run it first. We'll set the utility project as the startup project, and then it was AZ menu inside of that I'm going to set as the startup object. Okay, and I'm going to hit start. It builds. Okay, I could carry on for hours and hours and hours and fill the whole day with just going, what's going on? Again, you might start banging your head against the brick wall. Something else is not quite right. Let's look at what. And I'm not saying this is definitely always going to be the case, but these are the sort of things you look at. What is CCAT sub? It's a library. Oh, but for some unknown reason, it's declared it as an application. Okay, that's not quite right. Is it a bug in SyntaVS? Maybe, but that's not the point. The point is, little settings like this will affect you. So I'm going to set that to an executable library. My utility subs then, I've got a feeling that could be the same. Oh yes, it is. I'll set it as an execution library, or executable library. Now remember I talked about ELBs and the environment variables for ELBs. If we go back to the CCAT sub and look on the build tab, it's not actually used exe:\, or exe:\dir, it's used bin debug x64. Well, I don't want that. I want my alvdis, because that's the logical that I've used forever and a day, and that's the logical I use on my deployment machine. Okay? And that's obviously going to be the same in this, I'm guessing. So I'll look on build. Yes, it is. So let's get rid of that and put alvdis:\. Okay? Let's save all of those. And then let's just double check this is going to work, because it could be a break issue that it's running and failing. So we'll put a breakpoint in as well. Unlike traditionally running a debug from Workbench, if you want something to debug in Visual Studio, you have to set a breakpoint. It doesn't start in debug mode, you have to tell it to. So, That will hopefully build. It's going to build everything again because I've changed the project types. It does say build succeeded, and this time it ran. The window appeared, disappeared. Well, it's only gone back behind Visual Studio because I'm now in debug mode inside Visual Studio, debugging my 1982 Synergy DBL code. Okay? And I can press F11, and I can press F11, and I'm in TT Open. That's exactly the same as doing step and step in the previous debug. If I hit continue, the program will appear, the menu options will appear. So if it will run a bit slower in debug, we'll look at that. But it now functions exactly the same as it did. So I've now got a successful, pure Synergy traditional inside Visual Studio, building, prototyping. I've got full IntelliSense now, or I will have, and everything debugs and it works. Okay? I can't stress enough, I'm not trying to show a problem with SynVS. I'm trying to show you that doing slightly different things may cause you problems when you get to Visual Studio. It's easy to fix them, okay? Have faith, take a deep breath, stay calm. Are there any questions, by the way?
In .NET, you can attach to a running process with the debugger. Can you do that with traditional Synergy?
If you're running a DBR, you cannot attach to it with the Visual Studio traditional debugger unless you ran that DBR with -RD. So if you said -R, DBR space, -RD space, my program name, it would just run and you'd not notice any difference, and then you would be able to, in theory, attach with the Visual Studio debugger, find the source code and debug exactly the way you are. Thank you very much.